Did you know that there are as many neurons in your brain as there are stars in the Milky Way? These cells compose your brain and your spinal cord and are absolutely vital for communication in your nervous system. Without them, systemic issues could arise such as Alzheimer's disease, dementia, and even heart failure. Until recently, there were very few treatment options for these diseases. However, on December 3rd, scientists announced a very exciting event for people worldwide, the release of artificial neurons. These tiny silicone computer chips, such as the ones seen here, have the potential to treat neuronal degeneration. Today we're going to discuss the function of neurons, the recent discovery of artificial neurons, and how they'll be used in the future. Neurons fire in both chemical and electrical capacities. Electrical neurons send a signal through the nervous system similar to electricity. For example, when you touch a hot stove, the signal is initiated when your hand makes contact with the heat. The signal then travels up through the axon in the form of a chemical such as sodium or calcium to the spinal cord, where it is then sent to the brain and converted to a response. The response then travels back down the axons of the neurons, back to your hand, and causes you to remove your hand from the stove. This entire process occurs practically instantaneously. According to neurodegenerative disease research, when neurons fail to repair or replace themselves, neurodegenerative diseases can occur. These diseases can manifest themselves in both physical and mental capacities, such as in Parkinson's disease and spinal muscular atrophy. Until this recent discovery, these diseases were both incurable and progressive, eventually leading to death. TheScientist.com explains how scientists first went about their research. In the beginning, they used rats in order to help them understand the nervous system. They first implemented their artificial neurons in the hippocampus, which is a portion of the brain responsible for learning and memory. The specific neuron that they first replaced was found in the brainstem and was involved in breathing. They were able to record information about respiration in normal and healthy rats, and then replicate the firing pattern in their artificial neurons. Once surgically implanted, they were able to reproduce the currents and therefore treat degenerative respiratory diseases in the rats. At our current understanding of these microscopic silicone computer chips, we know that the artificial neurons have the potential to treat disease and essentially rewire the electrical currents within the nervous system. Still, this is only just the beginning, and more research needs to be done in order for these artificial neurons to be used beyond small neural units. In the future, scientists hope to use these artificial neurons to treat a multitude of different diseases. People suffering from Alzheimer's disease, Parkinson's disease, dementia, forms of muscular atrophy, and more can have hope in this technological advancement. According to neurosciencenews.com, there is great hope for people suffering from heart failure. Typically in heart failure, the neurons located in the base of the brain fail to send the signal to the remainder of the brain. This doesn't allow for the heart to beat strong enough, so not enough blood supply reaches the rest of the body. Further research could aid in the development of a new medical device termed a smart pacemaker. These smart pacemakers would stimulate the actual neurons instead of just controlling the heart rate, which would allow the heart to resume normal and healthy function on its own. In conclusion, neurons are essential for communication, and their degeneration can be absolutely devastating. December 3rd was a very exciting day for both the medical community and for individuals suffering from neuronal degenerative diseases. While further research still needs to be completed, this new discovery provides hope for new treatment options in the very near future. Considering that our bodies are composed of billions of neurons, only time will tell just how many diseases and people might be helped by this new discovery.